Okay, good evening, everybody.
What's up?
Hi, we're really excited to be here at ETH India, and we've really appreciated seeing all the projects and people gathering together. We're excited to see what's going to come out of this hackathon. My name is Zen.
I'm Leonard, and we are Taurus. So what we let you do is basically we let you increase your number of users because we make it easy for users to start using dApps without doing too much work. So most of you guys already know, if you've already played with any dApps, you have to download MetaMask, create a private key, get some ETH. Not sure how you're going to get it if it's banned in your country, but somehow get some ETH. And then you have to figure out what gas is, and then like what gas price, and then you have to make a transaction, and then make you sign something, you're not really sure what.
So that's a whole lot of different things.
Yeah, there's a bunch of things, right? And then when you lose your private key, then you lose all your money. So that's kind of troubling. So we've decided to solve that problem. What we do is we make it easy for users to start using your dApp today. So we tie Google accounts to private and public key pairs. And behind the scenes, how it works is we use a variant of Xiaomi secret sharing called distributed key generation to ensure that your private key is split into multiple shares stored on our backend servers, which are run by our partners. We run only one node and a bunch of them. And then when you log in with Google, you get back these shares, which lets you reconstruct a private key. All that sounds very complicated, but for the developer, all they need to do is include a script tag. And what this allows you to do is that the user will just use Google login, and he will give you access to like a Web3 object, which is the same as what MetaMask provides. So for most dApps out there, they already work. So Ethereum, here's an example dApp that's already live. It's using MetaMask. We've just injected that script tag that you saw onto the page. So in essence, if you do that on your dApp, you just log in Google, and that's it. So this works for any new user, even if you've not created an account with us. You don't actually need to create accounts. Just log in Google and you're done. Every time you log in, you'll get back the same private and public key pair.
Something really interesting as well is that we have the exact same interface as MetaMask. So if you're used to using MetaMask or incorporating MetaMask into your dApp via a Web3 interface or anything like that, using Taurus is exactly the same. You can swap out a MetaMask instance for Taurus and your dApp would just work.
Just go to our site, tor.us, and there's like a handy script tag there. It's called SHA hashes and everything. Make sure that the code that you get is exactly the same every time. So just put that on your dApp, and it should just give you a Web3 that a user can use straight away.
So this is a little bit more of how it works behind the scenes. As Leonard mentioned, we use this academic scheme called distributed key generation. This generates your key in a distributed fashion on the back-end side of the nodes. When a user authenticates using Google or any other authenticator such as GitHub, Instagram, whatever it might be, they take an OAuth token, send it to the backend, retrieve all these different shares, and then reconstruct the private key or in a separate JavaScript context in your front end. This ensures that the shares are directly sent to the front end itself, and the key is only ever reconstructed in that front end. Once the browser is closed, the key is lost and it's not saved anywhere, it disappears, and the user therefore maintains its security in that way.
The next time you want to use the dApp again, just log in again and you get back the same key. So we are sponsors, so we're sponsoring some API prizes. There are a few criteria for this, so let's talk about the amounts. So this is the grand prize, and there are 4 runner-ups. They fulfill different categories. They're all listed here. We also have more information on our site, as well as our flyers. But most importantly, we want to let you guys know, whoever's working on that, integration is really, really straightforward. If you guys don't know how, just go to our website, copy-paste, just try it. It doesn't take that long. Copy-paste the script tag, put it in the index.html page of your dApp.
You guys can do it now. Like, you guys can just include it now and it'll just work.
If you want to try it without using your dApp, right, just to see how the interface looks like, you can go to app.tor.us. That's where our mobile wallet's hosted. Just on your mobile phone, it should just work. It's just JavaScript. And you can log in Google and see the interface. That same interface will be what a normal user will see when they're on your dApp.
So this is just extended criteria. The grand prize is 60K INR and ETH, and we have several runner-up prizes as well. So that's us. I saw actually several hands in the crowd trying to ask questions. So we'll address that now.
So where is that particular private
Thanks for asking that question. We get that one a lot.
Yeah.
Leonard, do you want to take that one?
Sure. So behind the scenes, we use distributed key generation, right? So how this works is your private key is split into many shares, and you require majority of the shares to put them back together to get a private key. So all of these shares are run on our backend nodes. So we don't run the backend nodes. We provide the software. It's much like an Ethereum node. We create a software, but our partners are running it. So right now, for example, we have Binance Labs running one of the nodes, as well as ETC Cooperative and a few other people running nodes. So your shares are split across these nodes. And then when you log into Google, you prove to them that you are who you say you are on your Gmail account. Like, for example, my email is leonard@us. Google is going to give me an ID token, the sign by Google, that says that this is who I am. I send it to these servers, and then these servers will return to me the shares.
The consensus model is really similar to Libra. So basically, large ecosystem stakeholders run nodes. It's a permission setup right now. The reason why we went with this initially is because it's better in terms of a new project coming out in key management wise. In the future, we envision shifting this to a fully decentralized platform.
Yep.
At least have one part of the shares with us. If the particular key is divided into different parts and it is provided with someone other than us, it's not secure, right? Someone else has my private key, even if it is split, assuming they all are the same nodes. And if I don't,
they're not the same nodes. They're not the same. All run by different nodes.
Okay, it is.
Yeah.
Okay, but I'm saying, assuming if something like that ever happens, I don't even have a single node like share to make sure that they cannot reconstruct without my knowledge.
That's true that there's a security assumption.
Yeah, it's an honest majority of nodes. So it's the same as like a lot of other like consensus models for around permission systems. So you could, if you want, you could actually export your key and use it elsewhere. So if that's something if you're more concerned about security, our approach is incremental security, right? A new user who comes online, when he starts using a dApp at the start, he's not going to have a lot of money. He wants to get started really quickly. As we go on, we're going to ask him to have more permission, more higher security measures, like putting a password on top of that, having like a backup for that, using even a hard wallet to export a key. So we are incrementally providing more security. But for most new users, this is a great way to get started.
Those nodes are created by Taurus?
So we run a...
What is the maximum nodes? Like how many nodes you have?
So right now for like our version, we have around 7 partners that are running these nodes. So the threshold is like more than half of them, and we are getting more onboarded all the time. So to answer your question, what's the maximum limit? There's actually no theoretical maximum, just slower to generate keys. So it's really just a trade-off.
Oh, anyone can add a node.
You can run your own server, yes. So if you are interested in running one, let us know.
Not necessarily. For us, in the initial setup, it's a permissioned model. So they basically have to nodes fulfill a certain criteria in that they are large ecosystem stakeholders.
You can run a node, just not part of the same network. So if you're interested in running like your own like cluster for your own purposes, you can. Yeah. But to join this mainnet cluster, you have to be part of this set.
Exactly.
Any questions? The integration is pretty straightforward. Just try the script tag. It won't even take long. So most dApps we talk to get it integrated in like a few minutes. Go ahead.
Okay, you are generating public and private key using the Google login system. So if I leak my private key once, so is there any way to regenerate another private key or reset the full setting?
You can have multiple keys pegged to this account. So if you've lost your key, or if the security of it has been compromised, you can reset and create a new key.
How? I am just logging in using a button. So where is the setting of recreating another set of keys?
On a technical sense, on the back end, all of these are actually just mappings. Mappings to your Google account, mappings to your Instagram account, mappings to your GitHub account. And this is basically done through a request for a new key. you will definitely have multiple keys. You would then have multiple keys assigned to your Google account, and then you would choose which one you want to use.
To kind of paraphrase what Zen has said, it makes more sense to think of your mapping of your Google identity to your key as separate, completely separate data structures, which is how it's implemented in the backend. So your Google email is not used as a seed to generate any kind of like cryptographic key. It's not. It is just a mapping. When you request for it, we assign one of the pre-generated distributed keys to you. And this mapping is stored across all the servers, and they sync up on that.
Yeah, I got it. But do you have this feature built in?
Yeah, it's available.
Yeah.
So additionally on top of that, right, if you want incremental security on a particular key, in the future would be
Supporting
it's
more
already
logins.
supported on the back end, but on the front end we'll be providing more logins such that you can pair multiple
Like
of these
LinkedIn
logins to
or
one
GitHub,
public-private
yeah.
key.
Cool. Any other questions? Go ahead. Skip. Yes. How are you going to lose your private key? Quick question. What do you mean by lose your private key?
I mean, you said like there is a facility to have the same another private key linked to that Google account, right? There is a mapping.
He can have multiple private keys to a single Google account, yes. But how are you going to lose your key? Just quick question. How do you plan to lose your key? Do you mean like you accidentally leak it somewhere? Or do you
Yeah,
mean
leaking,
you...
yeah,
oh,
leaking.
leaking. Okay.
Yeah, sorry.
So you mean leaking your key? Yes, you can...
So
that's
okay,
possible, yeah.
I came to the platform.
Yes.
I lost my first private key, so I have created another account.
Yes.
So all my data of first private key was lost, right?
So what do you... this sounds different from what you said about leaking keys. So you mean leaking keys meaning you accidentally give your private key to someone? Or you lose your private key, you lose it on your computer or something? What do you mean by...
something like that, sir.
So
You don't have to store your private keys on your computer with our solution, right? Because the shares are stored on multiple servers. You just need to log into Google to
So
get
how
back your
secure
private key.
is that then?
So you
We
use an academic scheme called distributed key generation. It's from a paper written in 2002. You can check it out. It's by Cashin et al. Yeah, we can talk more later. I can share with you more details. Any other questions? Go ahead. So a share is kind of like a... It's easier to explain it with some diagrams, but you can think of it like this, right? A straight line, if I give you 3 points on a line, right? You need at least 2 of these points to get back the line. With just a single point, you cannot retrieve the line, right? Because any number of lines can go through this point. But to retrieve this single unique line, you need 2 out of 3 points. That's 2 out of 3 secret sharing, right? So they basically use that with higher number of powers for more servers. And we don't just generate a single line, we generate multiplies.
the scheme itself is called Shamir secret sharing, and we don't actually implement that itself. It's just we build off that. Distributed key generation is a scheme which is built off that.
Right.
Which, yeah. But in essence, that's what a share
That's what
is.
a share is. It's like a point on this polynomial.
So this is analogous to the mnemonic words that are used?
No, it's not. A mnemonic is kind of just a human readable way to represent a really large number, right? So all of those words that you see represent some hex, and then that hex is just concatenated from a really large number. That is just your private key. But each of the shares is as large as one of those keys. So yeah,
Thank you.
no problem.
My question is,
Okay.
my question is, how do you came up with this idea? Is this anything connected to Shamir's secret sharing algorithm or what?
It's exactly the same.
It is Shamir's secret sharing, but Shamir's secret sharing is not secure. So there's a long history of research after Shamir's secret sharing. So we basically took one of the more recent papers, which is still pretty old, 2002. So we took that paper, implemented it with the help of a professor, and then after that we ran a bunch of tests and had some audits. So that's basically how we got it done. Is this a question?
Okay.
Thank you. Any other questions? No? Okay, so our Telegram group is Taurus Labs. You can just find it on Telegram. If you guys, yeah, so there's a QR code here. You can actually just go scan this if you want. That should bring you to where you need to be. And for anything else, you can always ping us on Telegram, and we'll be there. Thank you so much.